Hello everyone, welcome to the next video in my Nix series. In this video we're going to talk about Nix Flakes. I think Nix Flakes are super cool. We're going to talk about how I use Nix Flakes, how you can use them on a per project basis, what are Nix Flakes, how they kind of fit into the ecosystem. I think for me Nix Flakes is really where Nix made a lot of sense, and I could see how I could go about in my day-to-day, how it would make it easier for my config to be shared and be more reproducible, how I could use it in my personal projects as well, like let's say I'm building a CLI tool, etc, etc. Before we get into what Nix Flakes are, I just want to talk about kind of the problem they're solving. And kind of before Nix Flakes, we used to use channels, and of course people still use channels. But from what I understand, what channels were or are a way to reference remote Nix expressions and retrieve kind of the latest version of these expressions. So for example, you might have an expression pointing to Nix packages, where Nix packages is a huge list of Nix expressions for installing software. So you can kind of reference in your Nix expression that you want to install VS Code, and you'll be referencing like a channel, and then that channel will have an expression, again being the set of instructions of how to install this package on Nix. So let's say we have a channel called Nix packages. If we take a look at what it actually represents on our system, it'll be something in Nix store, as most things with Nix. And essentially, what I understand a channel to be is you can think of it as the latest verified Git commit of a Git repository. In this case, the Nix packages repository is, I think, the most common one that we have channels for, but other channels do exist. And within those channels will be pointing to a branch typically. And whenever the latest verified version of a branch is available, that's what we will then use. So you can have a channel pointing to the latest stable branch, which will be 2405, I think, at the moment. And then you also have the unstable branch, which gets like more frequent updates. So if you want to have more of a rolling release system, you could do that, make it a bit closer to, say, Arch. And with R1, we have NixOS, which is pointing to this stable branch, which again doesn't get very many updates, 2305. And then we've got Nix packages, which is pointing to the unstable branch, which will get more, as we said, rolling release updates. Now, one of the problems we have with Nix channels is how do you share them across machines? Because if you're pulling the latest version of an expression, it means if I want to share it with someone else, in a couple of days, perhaps what they're building is different to what I'm building. And so you kind of have Nix Flakes, which solve this problem. Not those kind of flakes. These kind of flakes. Nix Flakes. So essentially what it allows us to do is to lock our inputs and put them into code in some way. And if you've used dependency management tools like npm or Poetry for Python, you've probably seen something similar to this. You have a lock file to kind of improve reproducibility. So multiple people can use that same project and get, in theory, the exact same versions of packages that you're getting. And it provides a more consistent experience between, say, multiple developers or multiple users. And also then, as an example, I always love to go to CI and local. In theory, your CI and local environments are much closer and much more similar. And you get that reproducibility, and you get those exact same environments, or in this case, the exact same dependencies or packages when installing. So some key features of Nix Flakes is they lock our inputs. We can use Git repositories, so they're very go very in tandem with Git repositories, which lots of our projects will be Git repositories, and we want them version controlled, so that's fantastic. And they really help improve reproducibility because we're locking our inputs and putting them into code. So anyone with this project now has the same inputs as we do, rather than pulling like the latest versions of a channel. If you forget to update a channel, you're running an older version, etc, etc. But now the inputs are locked until someone explicitly updates the inputs. And that's pretty cool, in my opinion. So, how do we get started? Good question. Well, there's a few ways we can do this, depends on your specific setup, but if you're just using Nix, edit your Nix config file, and add the following line. Enable Nix command and Flakes as experimental features. One thing that's important to note is that Nix Flakes are still experimental, and they could be breaking changes. So if you really are worried about that, perhaps it's something to avoid. I do think that the pros of Nix Flakes outweighs the cons, but it's just something to keep in mind that there could be breaking changes in the future, and there's no guarantee of APIs and etc. etc. But for me, and I think a decent amount of the Nix community, I think lots of people from what I've seen are using Flakes. Most of the Nix configs I've seen on GitHub, rather anecdotal, but again, do your own research on that. If you're running NixOS, we can go to our NixOS configuration, which by default is going to be in this etc NixOS configuration file. Open that again. In this case, we're using NeoVim. Add this line that you see at line 10, Nix settings, experimental features again, and we want to enable Nix commands and Flakes. We could also do this via the CLI every time we ran a Nix command, but it gets very tedious, so I recommend putting in your config and enabling it that way. Then rebuild your config as you normally would. Finally, go to the project that you want to lock the inputs of. So for example, if you've got a project where you are creating a dev shell and you want to lock the inputs, we could go there and run Nix Flake init, which will create a flake.nix file and a flake.log file. Open up our flake.nix file, again, just using NeoVim in this example. It will maybe look something like this. You'll have a description, you'll have some inputs and outputs. In our inputs, I think by default you have Nix packages, which is pointing to this URL, NixOS and NixOS unstable. So basically what we're pointing our input to this expression here, which contains all the packages basically we can install on the unstable branch, which is that rolling release branch that we kind of spoke about, which is constantly getting updates. So far, so good. Let's just swap to the flake.log file and see what happens when we add that input. The flake.log file will get updated, and it will look something like this. We will have a specific revision that it's now tied to of that Nix packages repository. And until we run Nix Flake update, this log file will not change, and we can specify specific inputs to update as well. We don't have to update everything. And we can see it has a bunch of information about the repository, a hash that you can see on line 7, which exists more if things aren't Git repositories, because they could be tarballs and various other things. But almost basically everything I've ever locked has been a Git repo, whether that be on GitLab or GitHub. So yeah, keep that in mind. But yeah, so we have this flake.log file, which is now locking our inputs, which is exactly what we've been talking about we want to do. And now what we can do is we can commit this lock file, we can commit this flake.nix file, and in theory, anyone using our expression will be using these exact same inputs. If we go back to our flake.nix file, if we go to our outputs, we can now pass Nix packages as an input. And actually, Nix Flakes are quite flexible in what you can output. You could output building a package if you wanted to. You can output building a dev shell, which you can create this kind of temporary development environment. I'll do a more in-depth tutorial how you can do that for perhaps a Golang project, which I've done for my own Golang projects, like for a CLI tool or something. You can also produce NixOS configurations within a Flake if you want. So you don't have to have it in etc NixOS configuration as we saw earlier. We can have it in a Git repository. For example, I have my Nix Flake Nix configuration in my home directory in .files. And then I just build the NixOS configuration. There's a whole bunch of stuff. We can also build like Docker images. It's pretty flexible. I think there's a load of stuff you can do. I've probably only scratched the surface myself, but it's just good to know that the outputs are very, very flexible, what you can do. And you can do a lot of stuff, and you can even specify when you're building the Flake or referencing the Flake what thing you want. Do you want it to build a package? Do you want it to build a Docker image, etc., etc.? For example, if we wanted to just point to our existing Nix configuration, we could do something like this. Specify the system, specify the module to import which is our default configuration. Again, doesn't have to be an etc nixos configuration.nix. Obviously, one of the problems with this, to edit this file, you need sudo permission every time. Maybe you don't want that. Maybe you want to just keep it like I have in a repository in your home. If we take a look at a demo now, we can see here we're just catting our flake.nix file, which is producing this dev shell. We can do nix develop, and we jump into this dev shell, and we can see that Golang exists within this dev shell. So I will use something like this for my Go projects. I've been building a Go CLI tool. Recently one actually to help with Nix, just more for fun than anything else, which was just to be able to search Nix options on the CLI. So I don't have to keep going to the website every time. But yeah, you can see so kind of the flexibility of Flakes, and you can see how we could potentially start using some of this stuff in CI as well, which is what I've started experimenting with. One other super cool thing we can do is reference remote Flakes. So for example, in this case, it's NixOS Anywhere, which I use to set up new machines. And you can see here, I don't actually need NixOS Anywhere specifically installed on my machine. I can just do nix run, point it, and then pass some extra args. In this case, I'm telling it what flake to build, this VM flake. I'm giving it an IP address and the name so it can SSH on and start running and doing a Nix install for me. It's really cool. At some point, I'll probably do a video on NixOS Anywhere and Disco, so you can have this kind of full Nix build. And maybe even you can, I think as I've said in a previous video, you could have a custom ISO, so we can, do a whole kind of Nix build there, which is really cool. Thank you very much for watching that video. That's basically it. Hopefully that gave you kind of a quick introduction to what Nix Flakes are, the problem they solve, perhaps some of the limitations, particularly around them being experimental. I'm obviously a bit biased towards Nix Flakes because I use them in basically every project I start now, and they're a big part of my Nix configuration. But yeah, let me know if you have any ideas for future videos. I think I'm going to start a new series about sharing some CLI tools I use that aren't perhaps as widely used or don't have like YouTube videos made about them, and hopefully you'll find that useful. I use Nix, by the way. I don't know if you guys had heard.